First thing we do is change f of x to y. And then I switch x and y. And then solve for y. So now I'm going to minus the 4. And then to get y by itself, I'm going to times both sides by -2. And I get -2x minus 4 equals y. And then write it as f inverse is -2x minus 4. Or if you prefer, you can distribute it through and write it as -2, x plus 8. Okay, but don't forget to change the y back to function form. Okay, so again, I change the y, f of x to y, and then switch the x and the y, and then add 1, divide by 3, so I get x plus 1 over 3 equals y to the 4th. How do I get rid of 4th root? I do the 4th power, and get the 4th power, and just leave it as x plus 1 over 3. And then I write it as f inverse, again, is the 4th root of x plus 1 over 3. Okay, same thing again, 4 over x minus 1. Switch the x and the y. Now I want to solve for y, but I can't solve for something in the denominator. So I'm going to times both sides by y minus 1, because see what happens when I do that is this cancels. Okay, now I do not need to distribute through here. This is really, really important. You do not need to distribute through there. I'm solving for y, so let's read what's happening. Y minus 1 times x. What's the last thing I said was times x. So we're going to divide both sides by x, and look what we get. 4 over x. Do not distribute through there. Okay, now I need to get rid of the 1, so y is 4 over x plus 1, and my inverse is 4 over x plus 1. Don't forget to write it in inverse form. Okay? Okay, this one is solving, so we have to factor this. It is e squared. So it is a quadratic. It's e to the 2x. So remember, we look at the 12. That part you do automatically and get factors of 12 that add to -7. -3 and -4. But this part you're doing without thinking. If that were x squared, we'd put x and x, wouldn't we? Well, it's not x squared. So what times what gives me e to the 2x? Well, if I write it like this, it's a little easier to see. So I put e to the x here, and that's why it makes this a little bit different. But it's still just a quadratic. And now I can just set my factors equal to 0. I get e to the x equals 3. How do I get rid of an exponential? I use a log. And my base is e. So I'm going to natural log both sides. And the x comes to the front, and this goes to 1. So I have x equals the natural log of 3. And you can just leave it like that, because it says please give exact answers. So we just leave it like that. And then I do the same with this one. I go e to the x equals 4, natural log it again, and I get x equals natural log of 4. Now, if it was natural log of a negative number, I wouldn't include that because it would be a extraneous solution, it's called, because I can't log negatives, okay? Now, remember with logs, I need one log. I cannot solve. It's like if I had this, x plus 2x equals 5, you wouldn't try and solve this without putting it together. So it's the same with logs. Let's put the logs together. What is the rule for putting logs together? When I add, I multiply. They have to be the same base, but then I multiply. And I get log base 4 of 8x plus 8 equals 3. Now I have one log. I can get rid of one log by exponentiating or using the rules of changing exponents. So let's exponentiate first. And then this cancels, and I get 8x plus 8 equals 4 cubed. Or remember, when we first started doing this, we learned how to change a log to an exponent by the base of the log is the base of my exponent. The power is the answer to the log. And look, I get the same answer. So either way, it's going to work for you. So I have 64 equals 8x plus 8. And then I minus the 8. And I get 56 equals 8x. And I get x equals 7. And then you plug it back in and make sure it works. Log base 4 of 8 plus log base 4 of 8 is log base 4 of 64 because I multiply, and that does equal 3. So I know I'm right. Okay, this is the decomposition. This one just says set up. We do not need to solve it. So we got to figure out how many fractions we need. How many factors do I have? I have 3 here, 2 here, and 2 here. So I need 7 fractions. Now I need to remember what I do with a repeating linear. I do x cubed, x squared, and x. If it's linear, I just put the a, b, or c over the top of it. This is another linear, but it's also repeating. So I do x plus 2 squared and x plus 2 and put a d and an e over it. Okay, now this one is quadratic. It's the factor, not, I know that this is a squared, but it's the factor we're looking at. So this is a quadratic factor, and it also repeats. So I do the same thing, do one of them squared, doesn't matter what order, but over a if the quadratic's in the denominator, on top of it, I put an fx plus g, and then an hx plus I. And that is all you need to do is set it up. The next one